Okay, we're going to talk about multiplying fractions, decimals, and whole numbers today. So our last problem string we looked at, we were multiplying 25 times 32. And when looking at this equation, we considered a couple strategies to help us solve. So we first looked at doubling and halving, where we take both factors and we double one. In this case, we doubled 25, and we halve the other. And in this case, we halved 32. And you can continue to do this process until you get to a very easy, friendly equation that's simple to solve. And in this case, we ended up with 100 times 8, which is 800. Okay, and then the next one we did was partial products, and we also call this the area model, and we used an area model to help us solve. So we broke up the number 32 into 30 and 2, and 25 into 20 and 5, and we partitioned our area model into these sections so that we can easily multiply length times width, length times width, length times width, and so on and so forth. And each one of those helped us develop a partial product. So in each one of these boxes, the numbers came from the length and the width, which is how we ended up with these partial products. At the end, we added them all up, which gave us our answer, or our product, and that was 800. Okay? Another strategy or route that was chosen was the standard algorithm. The standard algorithm is a set of simple steps taken to find the product. So we use this strategy and still got the answer 800. And then another one that we used was ratio tables. Okay, so a ratio table could have been done by using 1 and 32, or we could have also done 1 and 25, and the goal would have been to multiply 25 by 32. Okay, and as you look at a ratio table, every time you look at, it's input output almost. So 1 times 32 is 32. 32 times 10 is 320. 32 times 20 is 640. So we use this section up here to help us with whatever other factor is by multiplying it to see what the product is. This can also be used for dividing and finding equivalent fractions. As we continued on, another suggestion that we used to solve, which was a unique strategy, but again, very useful, was a numerical expression that could be written. So when considering 25 times 32, okay, so our original problem was 25 times 32, we can look at that problem and say, okay, well, to make this a little bit easier or more simplified for me, I know that 25 times 32 would be the same as 25 times 4. And then if I multiplied that by 8, which you'll see this expression down here. So I put the equal sign in the incorrect location. Sorry about that. You'll notice that I took my 25 times 4 because I know that that's easily going to get me to 100. And then I multiplied that by 8 because 4 times 8 is 32. So it will be the same thing. These are all excellent strategies and tools to use. Very important that we're not forgetting how to use these strategies. So that's just a real quick review of what we did yesterday. We're going to continue on off of this problem today, and I will talk to you in the next slide about how